Hello class, we're on chapter 2, lesson 2, the coordinate graph. And today we're going to learn about graphing, and we're going to start with a very simple graph. Let me get my pencil here, and let's go ahead and read. We have an illustration here of a patient in a bed, and the doctor's drawing this graph, and it's going downward, which apparently doesn't mean something good. And if we read the patient simply saying, "I really look forward to your cheery little visits." Okay, laughter subsides. According to the chart on the wall, this fellow's progress in the hospital doesn't look very encouraging. What the doctor has been drawing each day is a coordinate graph. It's called a coordinate graph. The patient's health is a function of time, and this is evidently what is being pictured on the graph. The coordinate graph is one of the simplest yet most useful ideas in all of mathematics. Invented in the 17th century by French mathematician and philosopher René Descartes, it has been used in a wide variety of applications ever since. To construct a coordinate graph, we begin by drawing two perpendicular lines as shown in the figure in the right. So we look over here, we have, if we were to draw the x and y, I'm just going to draw it by hand, and you would simply have, oh, I need to have my white marker. Let me go back and get that. Looks like the teacher wasn't prepared today. But we're going to just draw a line, a vertical line, and a horizontal line. Not perfect, but that's all they really have here is just a horizontal line and a vertical line. Imagine that's a little more vertical than what it is, but we have these letters that signify things. Let's read what they are. It says to construct a coordinate graph, we begin by drawing two perpendicular lines as shown in the figure at the right. The two lines are labeled with letters, usually x and y, as shown, and these are called axes of the graph. The horizontal line is ordinarily called the x, so that's why we have this x over here. This is our x-axis. Just going to put little commas around it, little quotes. This is our x-axis, all right? And let's head up here, and what do we have? The other one, the vertical line is called the y-axis. Okay, here's the y-axis. Okay, so we have to know the horizontal is x and the vertical is y. Okay, now what's this big O over here? Well, the O, the point in which they intersect is labeled with the capital O, and it's called the origin. Now, typically you won't see that O, but we need to know that the O is the origin, okay? And we'll also find out a little more what the origin represents. The axis continued indefinitely in each direction from the origin. Okay, let's turn over to page 74. Now, each axis is numbered like a ruler. Okay, so we're going to move over. I'm going to get rid of this, and we're going to focus on my little graph over here that I've drawn using other tools. As you can see, the lines are straighter, but let's go ahead and, you know what I'm going to do is I'm going to draw it right in here so you can see. I'm going to maybe take a real thick, dark color, and we're just going to make a line here. Okay, so let's say that was our y-axis, right? And then we're going to make this our x-axis. So all we've done here is we've drawn something similar to what we see over here on page 74, which is a coordinate graph. Each axis is numbered like a ruler beginning with 0. So I promised you we'd talk about the origin. Well, the origin, its value is 0. So we need to always remember that this is 0 down here. I'm just going to draw a 0. Oops. Okay, so we put a 0 here. And then each value increment, I mean, you'll notice that in different graphs you may use different incrementation of value. Generally, we keep it as simple as single, counting numbers, 1, 2, 3, 4, and we're just going to go to 5 as they did. Okay, and as you go up, we have the same 1, 2, 3, 4, and 5. Okay, now generally speaking, if you're going to go over 1 here, you should be going up 1. This shouldn't be 10, 20, 30. In some cases, graphs do change to a certain for certain reasons. They may change these values and they may not necessarily be proportional, but in most cases we're going to stick with just these values, okay? The single value, and what we're trying to represent here is a coordinate point. We don't really say what this means. We're just given a value of 1 and a value of 1. And we know that when we go 1 and 1, we're right here and sort of like forming a perfect box over here, right? So we can see that the value is equal, okay, in terms of the distance that's being traveled. So in the beginning, that's what we're going to focus on. It'll help us to draw better graphs. So generally, you should try to number your graphs and then place the values as your problems are dictating in terms of the answers or the values to tables. So let's go ahead and keep reading. It says to locate a point such as the one named P at the left, they have the letter P, and I'm just going to go ahead and put it right there where they have it. Oh, I need to get a black marker now. Let's go here. So we have this letter P. This is the point, and they just put the letter P. Okay, so what is this P and what does it represent? Well, we have to move along the x-axis until, so if we want to name it or give it a value, we have to move along the x-axis until we're directly below the point. So we would move over 1, 2, and 3. So 3 would take us to the line that is directly crossing over that point. So we're directly below it. Now, then we move up directly up to the point itself, again, using counting units along the way. So we go 1, 2, so now we're at 2. So we moved over 3, and we moved up 2. Now, they are written in parentheses and separated by a comma. So we went up 3. Let's go ahead and write that. We had 3, comma, 2. And then parentheses. Now these parentheses are different. We're not writing an expression here. We're not using this in an equation. This is just a coordinate point. Okay, so let's sort of set aside the purposes of parentheses that we use them and just note that we're writing information. We're defining what's a coordinate on the coordinate graph. So it's parentheses, a value, comma, another value, comma. And you'll note that the x is always given first because we always move in the direction of the x-axis first. So we always go horizontal, then we go vertical. So if I were to write this, it would look something like this. If these are the x and y, the x value goes here and the y value goes there. So it would look something like that. In this case, we moved 3 across the x-axis and we went up 2 along the y-axis. And we found our point P, so we can define that as coordinate point 3, 2. Okay, so it's 3, comma 2. Because a function can be represented by pairs of numbers in a table, these pairs of numbers can be used as coordinates of points to make the picture called a graph. All right. The graph of a function. So I'm going to erase our point P, and we're going to go ahead and follow this graph that they've drawn, and to do so I'm going to have to extend this out a little further. Let me get my my white marker back, and it looks like they go out well, they go out to 5, but I know that one point is going further. I'm just going to take this all the way out. Sometimes you don't really know the extent because you may just have a formula and you're going to plot points. In this case, I already have prior knowledge of where we're going, so I'm just going to draw this out to 10. I do know that we're going to go as far as 7. So the first point that they have, okay, if we were looking at the table, let's draw our table. Now they have two tables here, one that's vertical and one that's horizontal. Let's go with the horizontal first because we're used to that. We've been doing that. We did that in the previous lesson. And we see their values. The x values are 1, 2, 3, 4, and 5. And the y values are 3, 4, 5, 6, and 7. And each one corresponds to its x value. So for the value of 1 on the x, the y value is 3. 2 and 4 and so on. So now if we were to write these and plot these points, how would we write them? Well, based on what we said before, the x value goes first. So we would have 1, comma 3. That would be our first one. And so where is 1, comma 3? Well, we'll go over 1 and up 3. So this is where, oh, I need to get that black point. Let's go ahead and write these all out first, and then we'll go and plot the points. So we had 2, 4, right? And we also had 3, 5, and we had 4, oops, sorry, comma 6, and then our last one was 5, 7. Okay, so these are our 5 points. Now let me go get my black marker, and let's go ahead and start plotting. So it's the first one is 1, comma 3, or 1, 3. So we go over 1, and then we go up 3. So we plot that point there. Okay, so let's go ahead and just check that one off. All right, and then we have 2, 4. So we're going to go over 2 and up 4. Okay, it's very simple. All you do is match the line to the coordinate point, to the value across the x and y axis. So this is 2 and this is 4. I mean, we could sit there and count them, but you can just simply go by their label. 3, 5, so I go over to 3, and I go up 5. And when I say that, you got to be sure that you're not saying, let me see, go up 3 and over 5. That would have placed the point here, and that would have been wrong, because really that's 5, 3, not 3, 5. So got to make sure we always go in the right direction, and that's horizontal first. So 4, then 6. So we go 4, and we go up 6. And lastly, we have 5 and 7. Okay, we go over 5 and up 7. Okay, so I knew that value 7. I didn't necessarily have to go out and label all the way to 10, but a lot of times we will not know all the values. We won't have the table in front of us, so sometimes we'll just extend a little further with our labels, or sometimes we maybe have to add to them if we realize that we needed to add more numbers on our coordinate axis, just so that we can clearly see where we have to put each of these points to plot these points. So now we can also write this table as they said. Let me go get my marker. I need the white marker. And if you notice all the way to the left, it says writing the table in the columns rather than rows has been done at the left and makes the paired numbers easier to read. So sometimes people like to do that. They'll just do like an X and a Y table, and then they'll just put the values, and we're going to use the same values here: 1, 2, 3, 4, and 5, and the y values were 3, 4, 5, 6, oops, and 7. Now you might notice that it looks very similar to what we were doing here, except we were actually using the coordinates. But if you do it this way, try to put the x first. Don't put the y and then the x and then confuse yourself, and challenge yourself to know that the x should really go first. We should put them in this form. And then there are cases where we don't necessarily use x and y. They may be information, there may be labels for even these particular points, as we use these coordinate graphs for different purposes. So we're not just bound to x and y, but we're using this initially so you can see, of course, we had the x-axis over here, and this was the y-axis up here, right? That's how we originally started. So so we know which direction we go with each value. Okay, and that's it for lesson number 2.